So version 2, inverse tangent of negative rad 3 over 3. We're looking for an angle, and that angle has to be between negative pi over 2 and pi over 2. Tangent of that angle has to be negative radical 3 over 3, and that's going to be negative pi over 6. Just wanted to give you a heads up. In the version 1 video, the very first one, I went into a pretty lengthy explanation of why we have to limit the value of theta here to between negative pi over 2 and pi over 2, and why we have to limit the value for theta, the angle, to a certain interval. And if you would like that further explanation on why we're doing that, I would urge you to watch that first video that I made for the version 1 part of the test. Alright, so anyway, I'm just going to focus on answers in these videos. Inverse secant of 2 is the same angle as the inverse cosine of 1/2. So we're looking for the angle in which the cosine is equal to 1/2, and that angle between 0 and pi happens to be pi over 3. Problem 3. We first find the cosine of 4 pi over 3. Now the cosine of 4 pi over 3 is negative 1/2. And then we're trying to figure out the angle in which the inverse sine, or the angle in which the sine of the angle is negative 1/2. And again, that angle has to be in between negative pi over 2 and pi over 2. And that angle then would be negative pi over 6. For problem number 4, the inverse tangent of 1, well, that angle in which the tangent of the angle is 1 happens to be pi over 4. And the cosecant of pi over 4 is the reciprocal of the sine of pi over 4. Sine of pi over 4 being rad 2 over 2, so the cosecant would be 2 over radical 2. And then, of course, we want to rationalize our denominator. 2 times radical 2 over radical 2 times radical 2 happens to be 2, and those 2's would cancel, so we would just get radical 2. For problem number 5, we're looking for the inverse cosine of negative radical 3 over 3, and just kind of looking back at my diagram that I made in the other video. If you want further explanation, you can check out that other video. But the bottom line is we put theta, we're looking for a theta in which the cosine of the theta is negative radical 3 over 3. Without too much effort, we can figure out that the length of that opposite side, just use the Pythagorean theorem, the length of that opposite leg of theta would be radical 6. So we're looking for the tangent of the angle, and the tangent of the angle is opposite over adjacent, and the opposite leg is radical 6. The adjacent leg is negative radical 3. We can bring that negative out to the front, and then radical 6 over radical 3 can be written as radical 6 over 3, and 6 over 3 is 2. So the tangent of that angle is negative radical 2. And then problem 6, we're looking for the inverse, first of all, the inverse cosine of 1/3. And that has to be in the first quadrant. Cosine is equal to the adjacent leg over the hypotenuse. Let's let that value there be theta. And therefore, without too much trouble, hopefully, we can figure out that the length of that opposite leg is radical 8, which is 2 radical 2. And we're looking for the cosecant of the angle. And the cosecant of the angle, since the sine is equal to opposite over hypotenuse, then we're looking for hypotenuse over opposite. So that's 3 over 2 radical 2. And if we rationalize their denominator, we get 3 radical 2 up on top, and we get 2 times 2, or 4, down on the bottom. I'm much quicker when I don't explain every little detail, but like I said, if you do feel like you want to know why and maybe get a little bit more detail on any one of the problems, you could please do watch the videos that I made for version 1.